I'm the CMIP Panel co-chair, also a science fellow at the Met Office. I've worked on ocean, sea ice, climate modelling. In AR6, I was the coordinating lead author for the ocean, cryosphere and sea level chapter. So I think my background hopefully fits really well with EERIE, and I hope I can tell you lots about CMIP and my thoughts on high resolution. So I know there's quite a few perhaps early career scientists also involved in EERIE, so I thought I'd say a little bit of background on CMIP and CMIP7. And I should say CMIP stands for the Coupled Model Intercomparison Project, and it is part of WCRP, which is the World Climate Research Programme. So I'll talk about that first. Secondly, I'll talk about how CMIP has evolved, how I think HiResMIP2 will enhance CMIP7, and what other opportunities there might be. And then go on to talk about how we're thinking that CMIP might look even beyond CMIP7 and where high resolution could come in. So CMIP6. So there's a long history of CMIP. For anybody who's interested, there's a new paper in GMD led by Paul Durack, which talks about this history going back more than 30 years, where it was set up by a few modelling centres to compare their early evolving climate models. By the time we got to the 6th phase, there were 24 model intercomparison projects from 25 countries, more than 40 institutions with 130 odd models. They ran 300 experiments. There were a lot of citations. If you just look for the main citation, it actually looks quite low to me, around the 8,000 to 9,000 mark. But actually, if you do a search on CMIP, there's more than 40,000 citations of CMIP. So there's nearly 25 petabytes of data, which is sitting on the Earth System Grid Federation, or ESGF, data nodes, which are situated in many different countries. So it was a huge endeavour. And if you look at this figure here of the showing model complexity and the number of models, you can see as we go from green pluses to blue to red. So that goes from the 3rd, the 5th, and the 6th phase of CMIP. You can see how the number of models has dramatically increased, but also how the complexity has increased with aerosols coming in, vegetation, ocean biogeochemistry, etc. So for people who look at the IPCC reports, and here's the front cover of the Working Group 1 report from the 6th assessment, you can see CMIP data throughout that report. Almost all the figures of future climate come from CMIP. So this example here is showing the surface temperature projected changes at 1.5, 2, and 4 degrees of global warming. So CMIP has a massive impact on policy. Now, the structure of CMIP is that we have, first of all, a deck, so diagnostic, evaluation, characterization of clima, which includes standard experiments which help to document the model's behavior, both in terms of a long control with internal variability, but also things like the equilibrium climate sensitivity from experiments where you increase carbon dioxide by 4 times. And there's also experiments where it's increased by 1%. And in addition to that, there's also the historical simulations from 1850 to the near present. So those are characterizing the basic properties. We have the model intercomparison projects. And in CMIP6, this came bottom up from the science communities, and modelling centres decide themselves which projects they want to take part in. I think a really important part of CMIP is the aspect of the common standards and open access. There's a lot of work that goes on in CMIP defining these standards, coordinating, providing the infrastructure and the documentation for the models. And this is ultimately what makes it usable and accessible. So in CMIP6, as I said, there were many modeling to comparison projects. You can read about them in Veronica's 2016 paper. You can see high-res MIP here feeding into the regional phenomena. And there were three main goals in CMIP6: to look at systematic biases, the response to forcing, and variability, predictability, and future scenarios. And you can see how the various MIPs contributed to that. Now, if we think about resolution, now this comes from a paper in Nature Climate Change that I wrote with Malcolm and others. And we looked back how resolution had, in the ocean models, had appeared in the IPCC reports. So looking at the graph, and you can see that, that there haven't been many dramatic increases in the last few cycles in the resolution. In fact, possibly, a little bit reduced in their usage. And definitely not meeting where we think the finest possible resolutions could be. So in around the 2020 time of the sixth assessment report, high-res MIP and the Orca 12 type runs did appear in the sixth assessment reports, but they were nowhere near as high resolution as the very highest resolution that is possible in the community. And the figure shows how you might compare these. So you can, first of all, if you look at the coarsest resolution in the Southern Ocean, you can just about see the Antarctic circumpolar current. Even at 25 kilometers and the 8 kilometers of the 1/12 of a degree model, you can start to see the structure of that and the eddies. And then when we get to the finest resolution, which came from an ICON simulation at 2.5 kilometers, you can really see the Agulhas retroflexion taking place and the spin-off of the Agulhas eddies into the Atlantic. And of course, the same is true in the North Atlantic, where very difficult to see the Gulf Stream, perhaps, except as a blur in the coarsest resolution, and that is the resolution of many of the Earth system models, whereas at the finest resolution, we see all that beautiful structure, both in the Gulf Stream, but also in the Labrador current. So, conclusion is ocean model resolution is really now lagging behind the cutting edge model development. And, of course, this comes because there's this tension between how much computational effort you put into complexity and ensembles versus resolution. And this is in spite of the evidence from, the old now Minobi paper showing how the SST resolution was really important for capturing the rainfall band in the Atlantic. And this nice paper from Malcolm showing that it's only at the higher resolutions that you can start to capture the relationship seen in observations between SST and wind stress. And in fact, in the lower resolutions, say N96 with the Orca 1 degree type models, you're actually seeing the relationship in the wrong direction in some places. And of course, this other paper from Primavera, and thanks to Malcolm and others for this slide. And I think this is obviously really striking that if we look at the rainfall change over Europe, the projection from the very highest resolution model in high-res MIP actually sits on the very edge of the CMIP ensemble spread. And so that really begs the question, are the low-resolution models good enough? Or how do we combine this information for users? So how should they interpret one model projection that sits at the very edge of an ensemble spread in the context of many more projections? I don't have the answers to that, so I give you that as food for thought. And also indications that this is very much linked to what's happening in the ocean, as well as the atmosphere and the position of the Gulf Stream. So now let's move on to CMIP7. So CMIP7 has evolved from where we were in CMIP6. But before we even started on CMIP7 2 years ago, we were really pushed actually by the chair of the WCRP Joint Scientific Committee, Detlef Stammer, asking us, do you really need to do CMIP7? You've got 25 petabytes of data sitting there. Is this necessary? And so we did actually ask ourselves that question, really carefully. So one of the things we looked at were the science objectives of WCRP, and the 4 of them are listed here. And we still think that there are questions which cannot yet be answered in full with the existing model simulations. Questions about the equilibrium climate sensitivity, which many models were outside the assessed range in CMIP6. Questions about near-term evolution and how models or how the future will respond to changing aerosols. What will happen in the long-term response? So when can we better project the ice sheet melt? And of course, there are really important inputs from CMIP to the IPCC reports. So we felt that we were going to go ahead with CMIP7. And as a result of that, we've now defined what we see as the really important science goals for CMIP7, as listed here. And you can read more about them in the newly submitted paper to GMD, John Dunn, myself, and others on the CMIP panel. And the 4 goals are about patterns of sea surface change, how the tropical ocean temperature patterns will co-evolve with those at higher latitudes. So I think Rob might have something to say on this. Talking about changing weather and how dangerous weather patterns might evolve. The water-carbon climate nexus, how the Earth will respond to human efforts managing the carbon cycle, and including geoengineering or climate interventions, and points of no return. So what are the risks of triggering irreversible changes? Will we reach those points of 2 degrees, 4 degrees? What are the likelihoods of those as well? So those are the goals that we're trying to work towards. CMIP or WCRP, the landscape of that has evolved. So CMIP now sits within Earth system modeling and observations. We have now for CMIP7, we have an international project office for CMIP, which for something that has so many components with experiments and infrastructure designs has been revolutionary for CMIP. This has enabled us to have task teams and to link much better, we hope, with a whole range of stakeholders and users of CMIP, as well as the people doing work. Cordex, so the downscaling, for example, and other things like high resolution sit in other parts of WCRP. So the regional information for society, but also digital Earth activities are important. And so we're trying to build stronger links across WCRP with CMIP. What I hope people have seen in CMIP in the last few years is that there's been a much greater increase in engagement with the community. We have, and some of you may have been involved in one or more of these. So we have task teams which have enabled us to explore options, both for infrastructure, but also the design of the ensemble, the forcings, the benchmarking. We've had many surveys and drop-in sessions and consultations with the wider community. For any early career researchers, if you haven't come across Fresh Eyes on CMIP, it's a great resource to get involved. You can contribute to future thinking of CMIP or actually have projects and working with people in the wider community of CMIP. We have a CMIP website, which gives you all the latest information. And we now have 2 special issues for GMD, one on the CMIP7 scientific objectives and experimental design. There's already 4 papers in that, including high-res MIP2 and the CMIP7 description, and a second special issue dedicated to the forcings and the inputs for CMIP. So please, I encourage you to look at those and give us lots of comments. The basic idea, as we describe in Dunn et al., is that after we had a big consultation with the users, it was felt that CMIP6 was too big. We've moved to a more continuous approach with smaller targeted fast tracks, and allowing the community MIPs, so the science-driven MIPs, to run on their own timeline and not be defined by IPCC timescales. So alongside that, the deck will run, and we're also, as you will see, wanting to move to a more continuous update of forcings as well. So this design was approved by the Working Group on Coupled Modelling, also the Joint Scientific Committee for WCRP. So a few points is that we're really encouraging emissions-driven experiments as flagships for CMIP7. So I guess that does speak to the complexity side, but there will absolutely be concentration-driven options within that, and we will bridge that gap. However, I would say is that the early indications are that most centres will not make significant moves to higher resolution, and that is somewhat disappointing, maybe. So maybe that's something we can discuss as well, because I see that we'll have many models in the exploring the complexity, uncertainty, and we'll have high-res MIP, but we'll have far less models looking at the full deck and scenarios. And so what's in the fast track? There's roughly 2 parts. There's the prediction and projection part with the decadal predictions and the scenarios, where there are now 6 scenario experiments, and I will come back to those. And these are supported by a whole load of process understanding, but much less than in CMIP, the full CMIP6. This is about 10% of the size of the UK contribution to CMIP6 as a benchmark. So much more achievable on a short time frame. So we have aerosol experiments, detection and attribution, some land benchmarking, the C4 MIP, which is really about the carbon cycle and linking to this emissions-driven, the CF MIP, which is about the clouds, GeoMIP, which is about the climate interventions, and 1P MIP experiment, which is a short paleo experiment at 127,000 years before present, but it's a 100-year run, which is about looking at the Arctic amplification and using proxies they have there, and radiative forcing experiments. And these, as you can see, are linked to our scientific questions. So do look at the QR code if you're interested in more. So we have a timeline. So we hope that the models will start running soon. The historical forcings are just being finalized. I'll just show you that. Scenarios are in progress. We defined how we would do harmonization just this week, and we're hoping that the models will start so that they're delivered early 2027 in time for AR6 and be ready for downstream work by Cordex, impact community, and the iSheet modeling community. So the forcings, there are a lot of forcings data sets that we've had to juggle. You can see, and it's in the final column, that a lot of them are starting now to be published. So this is great. We're definitely, I was a little bit worried that we wouldn't be able to deliver on what we'd promised, but this is looking, really good, and we're so grateful to all the people who've really pulled it out to make this happen in that community. Similarly, the scenario paper will also now appear in that special issue soon. It's submitted but hasn't appeared, so please feel free to comment. But it has actually been out to community consultation at least twice. before even being submitted. So you can see the 6 scenarios, a high one, which isn't as high as 8.5 was, so that's more like the 7.0 level from CMIP6. Medium, so that's about the national determined contributions, where we are now. And then 4 low experiments, and it includes 2 overshoots. So overshoots is a really new thing for the scenarios. And in fact, a lot of these are extended beyond 2150, and we even have a high overshoot included in that as well. So there's, we're really interested to see how these will play out, particularly with the overshoots. Relevant to the high resolution community, I wanted to mention the reference evaluation framework. So this is something the model benchmarking team have pushed forwards. So we want to have a systematic and comprehensive benchmarking, comparing with the best available observational data. We're really happy that ESA and the US Department of Energy have supported this and its development, and it builds on many packages. So we haven't chosen one community package, we've taken a whole load, including the ESM Valtool package. And the idea is it will be community owned. It can be run either as the data is uploaded to ESGF, and the statistics and plots will be available from a website there, or you can download it and run it at your modeling center and see what's going to be produced before you've even uploaded your data. So at the moment, there are limited diagnostics in it, but still fairly comprehensive, but there is also scope for developing these. So an important question is, how well will this work with the high resolution model with that level of data? And Malcolm is very kindly going to be one of the first testers of this on the Met Office side. Or try, anyway, we'll see. So it will be open source and open access. So if people are interested in this, then it would be great to have further conversations. And we're also talking with people in Destination Earth who have a different package, but hopefully we can build some bridges across those 2 systems there. High-res MIP2 has evolved. This is a plot that's in the GMD paper. And, obviously we recognize that the Earth system models cannot capture all the important processes, and we do need high resolution. The protocol or the experiments obviously link well to the science questions, perhaps with the exception of the carbon one. But happy to discuss that further. I think, optimizing the high resolution climate models themselves will be an important step away from the traceable hierarchy, because it will enable the models to showcase the best they can do. And I think the experiments bridging to the DET, the scenarios, the kilometer scale models are really promising avenues for future research. And so, have you already shown this week, Malcolm? No, okay. So actually, I just put this slide in this morning. I didn't put it in originally because I thought, oh, Malcolm's bound to have shown this. So you can comment. Oh, actually, you can't comment because the comments have closed now on your paper. So this is in the GMD paper. You can see how the proposed experiments link to the CMIP. The CMIP and the DEC experiments and scenarios are in the top row, and the various high-res MIP2 ones are below that. So you can see how the present day and the historical runs can link to the variability, and good to see people exploring how the 1850 and 1950 spin-ups might compare between CMIP and high-res MIP, and other experiments which relate to the AMIP experiments and the scenarios. And we perhaps might want to discuss which particular scenarios we want high-res MIP to run with. Yeah, I know, yeah. Okay, so questions which I've hopefully said is, hopefully the experiments will bridge the gap. Do we need more to run the deck and the fast track? Can we benchmark with the ref? And it'd be really nice to see the downscaling, the impacts work, and the ice sheets model into comparison projects, which then feeds through to sea level projections, better linked to high-res MIP2. And I don't think we saw that so much in CMIP6. So we are having discussions about model selection with that community, and it would be good to bring the high resolution up at that stage. So another thing to discuss. So very briefly, in the last 5 minutes, where might we be going? And this is all very sketchy, and but good to get people's input. This is a paper that Christian Jakob and others produced, and currently things are much more perhaps seen as an ensemble of opportunity. Christian was arguing for splitting things in the research from an operational capability, perhaps along the lines of CMIP versus Destination Earth, and that's something we can discuss more. Other things that have been highlighted is this paper by Colin Jones, which I see is on the list of papers from high-res MIP2 because of the various, from EERIE, because of the various contributions on high resolution there. And this is really about how we can better link up CMIP with Cordex, with EasyMIP, with the integrated assessment modeling community. And so, and another slightly different view might be Veronica's view, where bringing in much more machine learning capabilities. And actually, when I looked at this, I was like, I feel like they've highlighted kilometer scale, but maybe not the kind of resolutions of EERIE that we're thinking, that you're thinking about. So that might be another thing to think about where it fits in. But what we're thinking in CMIP is to move to a more sustained mode of climate information where we're less dictated by the IPCC timelines, because we see that the information we're producing is needed more regularly than the phases we have. So we decided at a WCRP meeting to scope a sort of sustained mode for CMIP. And in that, we have kind of two ideas, and one is about extending historical forcings right up to the present day. So you can have up-to-date historical simulations to understand recent climate, like 2023. Nobody knows the exact forcings right now because CMIP wasn't updated, was last updated to 2014. So in this phase, we'll update to 2021, but already the providers are moving that on as quickly as they can. And also updated scenarios responding to changing policy, and on what timescale do we need to redo climate projections with new Earth system models? Not every year. Maybe every 5 years on the global stocktake, which is a more defined timeline, perhaps, than the IPCC. So the scoping's ongoing. I won't talk about these, but I can if people want to afterwards. Just about how we see it would play out if we had an annual cycle of the forcing updates, as opposed to a longer, perhaps 5-year or 7-year cycle of IPCC. And how we link with other activities going on in the wider climate landscape. So my final slide, so some food for thought moving forwards. If we had this, a focus within CMIP, but it wouldn't be the whole of CMIP, we still want science MIPs to continue the research. But if we had some work on a narrower focus, would this enable more high-resolution contributions? For example, doing regular updates of historical, is that more achievable? How can we best combine the information from the climate models at different scales, as I talked about earlier? And this could be, or will be called out in one of the Horizon calls. You know, I do worry about the complexity resolution question. So, you know, are there machine learning methods out there or that people can think of about how you can bring the carbon cycle to the high resolution models to kind of try and relieve this tension? And you know, a real problem, I think, is the spin up for the high resolution. We've seen this so many times. It's great to see a poster out there. I know there's more work going on in Oxford as well with other methods as well, which might be good to discuss. But it would be great if the push to high resolution could actually force us to try and solve or make big progress on this spin up issue, because it's such a problem for not just for the high resolution, but also the low. Yeah, and thank you. You know, if you please sign up for CMIP if you're not. We have seminars online, and which we've had some great speakers every month. There's mailing lists and loads of tools out there.